Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. So we're going to talk about inverse property of exponent law, which is the 11th law in this series. Okay, please make sure you've reviewed my previous videos and make sure you're conversant with those law. Practice with the worksheet, practice with the textbook. And if there's any question you're not really sure, please don't hesitate to send me an email and I'll get back to you. And also don't forget to like, share, and subscribe and click the notification bell so that when I post new videos, you'll be the first person to know. Now, the inverse property of exponent law, this law states that raising the logarithm of a number to its base is equal to the number, all right? I'm aware most of you do write, so I'm going to just write it down before I state the law. Okay, so this law states that raising the logarithm of a number to its base is equal to the number. Okay, so what I'm trying to say is if you have a log a x, are you seeing it? So that means you can see that the logarithm and the index, okay, and the base we're having here is the same. The logarithm base and the index we're having here is the same. The final answer will give you what? X, okay? Or you have exponential ln of x. So that is the reason. Remember we said exponential, so you can still write this again as logarithm. Sorry, you can write this again as exponential. Ln is the same thing as log to base e x. So you can see both of them are the same, and that will give you x. So that's the reason why when we're solving some questions, I will say to get rid of the ln, we take the exponent of both sides. So you're basically applying the inverse property of exponent law here. All right. So we're going to talk about this. I'm going to pick some examples to explain so that you can understand what I'm trying to say. Don't worry, in the subsequent videos, I'm going to pick some examples. We're going to solve some questions together. But what I want to do in these laws is that I want to state them first, then before we start solving questions, okay? So I'm going to pick some examples just to emphasize or just to show you how this laws is being used. So we have 5 log 3 to base 5. So because they are the same, it's going to give you what? 3. We have exponential ln 2, okay? Because we have that. So remember I told you ln is the same thing as log to base e, all right? So because it's the same thing, it's going to give you 2. Number 3, let's say we have 10 to the log of 10, log of 12 to base 10. And this is going to give you what? 12. All right? And that is the answer for that. So that's how you apply this. So basically, we'll be solving some questions. So when you have, let's say we have ln 2 is equal to something, and you want to get rid of the ln, you take the exponent of both sides. All right? And that is that for that. So the next law, which is law, I think this is law 13, law 12. Okay, the next law, law 12, we're going to talk about the base switch law. All right, the base switch law. And that's why it's very important that you click the notification bell so that when I post the video, you'll be the first person to know. So that is that. So remember the take-home message for the inverse property. When you are raising to a power of a logarithm and the base is the same thing as the index here, okay? The base here that you're using to raise, or the number of to its base is the same thing. You have to know that the final answer is going to be equal to x, okay? All right. Thank you very much. And don't forget as well that this property, especially taking the exponent of both sides, the exponent of a ln of a number is equal to the number. This is very important because we're going to be using this to solve loads of questions later. So don't forget that. It's very important to take note of that. All right. I will see you soon, and we'll talk about the base switch law. See you soon.